Attributed programming. CLR type information, otherwise known as metadata, is extensible through attributes. There are several built-in attributes already defined in the framework class libraries, such as serializable, flags, marshal as, some of which you've probably used before, especially serializable and flags. Now, these attributes are used extensively by the CLR to support serialization, security, interop, and many other things. We can also create custom attributes to allow user-defined metadata. Now, one thing to note about attributes is they do not actually change how the code that the attributes are applied to are compiled. They are simply added to the assembly's metadata. Now, only things that are interested in those attributes will actually query objects for them. So if you have a class marked as serializable, the only thing that really cares about that are things like serialization or possibly remoting, WCF, things of that nature, which also require serialization. But to anything else, when you create an object of type student, for instance, and it's serializable, it has no idea nor does it care that it's serializable. You can think about this as like sticky notes, the little post-it notes that you put on in books, etc. It doesn't actually fundamentally change the book. However, if anybody's interested in a particular topic in the book and you put a sticky note there to indicate it, well, then that person can find that note pretty quickly. And that's really all attributes do. Attributes are applied using the square bracket syntax. You've seen it before, again, like with flags, serializable, etc. And typically, it is going to be immediately preceding the object which you wish to apply the attribute to. Multiple attributes can be comma separated in a single set of brackets or independent bracket sets. Now, this is just a stylistic thing, and everybody will have their own opinions on what the best way to do this is. But if you wish, you can have all of your attributes, if they apply to the same item, they can just be all comma separated. Or you can have each individual attribute delimited with its own set of square brackets. Now, parameters to these attribute constructors can be passed either by position or index or by name. So it's very similar with optional parameters to standard C# methods. Now, with partial classes, a class level attribute can be applied to any piece of the class. So if you have a partial class defined in two different files, if you apply the attribute to one of the classes in one of the files, it applies to the entire class. Because again, the partial class is just a way for you to separate things by file. It has no bearing on the actual generated class. It's as if everything was in one file. Most attribute class names end with the attribute name, which can be omitted when used, because there's, like serializable, for instance, is actually known as serializable attribute when you look at the class definition, or flags is actually flags attribute. But when you use them, you can leave off the attribute name and it'll automatically find it. So it's just a nice convenience built into the compiler. Now, if no parameters are going to be passed to the constructor of the attribute, then you can leave out the parens completely. So sometimes you'll see the flags enum attribute with or without the parens, because typically you don't have a constructor, a parameter passed to the constructor of flags. So you'll just see it as flags without the parens or possibly with the pair of empty parens. So in the example at the bottom, we have a class called student. Notice here it is serializable, and then I have a comma with some other attribute. Now, some other attribute doesn't exist. It's just a random name I pulled out of thin air, just to show you what you could do with a second attribute you wish to apply to that class. So notice that is two different attributes, the first one being serializable, no parens, the next one some other attribute where I pass a parameter by position, and then I pass a parameter by name. It just so happens that the name is name. The big difference between this and using named parameters with the function call is you would use an equal sign here, not a colon. And then I have one more attribute called XMLRoot, where it sets the element name equal to student with a lowercase s. So that's 3 different attributes all being applied to the student class. How do we know that? Because attributes are applied to the next logical thing it can find in the code. So usually attribute targets can be inferred from the position of the attribute. As I've mentioned before, it's typically the thing that immediately follows the attribute. However, sometimes you cannot implicitly determine what the target of an attribute is. For instance, assembly attributes. The assembly attributes have really nothing physical for you to attach the attribute to. So to indicate an assembly attribute, you would just prefix the attribute with the assembly colon prefix. So you'd say assembly colon assembly copyright, as you can see in the bottom example. So that will indicate that this particular attribute applies directly to the assembly, not to like the next class or next function. We also have the ability to create attributes on parameters to functions. Perfectly legal. So you'd actually just put the parameter immediately before each parameter in your function call, where you define it. However, if you want to apply a value to the return value of a function, you would do something similar to the assembly keyword. You would use the return keyword, colon, to indicate that the return value of this function is going to have this attribute applied to it. So some of the named targets that you can have for attributes are assembly, field, event, method, module, param, property, return, and type. So those are the different things you can actually specify if you wanted to be explicit. Most cases you do not require those particular prefixes because it can be inferred. But things like return and assembly, there is no possible inference because you have to specify exactly what you're targeting. Custom attributes can be very useful in your code, especially if you have something that you wish to tag onto your class definitions that you don't want to have affect the actual running of those particular class objects. So if you create a new attribute, you will basically derive from the attribute class, and you will name your class something attribute. Now, attributes can have positional parameters and name parameters in their constructors. Okay, to define the named parameters, they basically just have to correspond to a property or public field of that particular class. And the positional parameters, it works just like any traditional constructor. How you define your constructors indicates how you pass parameters positionally. You can also restrict what your attribute can be applied to. Basically, you can say that your attribute only applies to methods, or it only applies to properties, it only applies to classes, or actually types. So each one of these can be applied as an attribute target. And the interesting thing here is, to apply those attribute target restrictions, you use yet another attribute called the attribute usage attribute. All types in the reflection object model, like type or method info, implement a getCustomAttributes method. This getCustomAttributes method returns an array of objects. Each object in the array represents an attribute of the target entity. So if I wanted to look for all of the attributes called something attribute that's applied to a given method, for instance, I would get a method info object that points to that method and specify that method info object dot get custom attributes, and then type of the attribute type I'm looking for. Then it returns an array of objects. If the array is empty, that means it was not able to find any of those attributes on that particular entity. You can then iterate through the array of the attributes, and then you can check for a match based on the information you are looking for. Remember, attributes are just there to be like sticky notes. So they don't necessarily affect how the code runs. But if you are processing values or you're trying to execute a method and you want to make sure, for instance, that it validates that a user is logged in, then you could apply your custom attribute called verify user, for instance, and then when that method executes, you could actually have a call to specify whether or not that method requires validation, and if it does, validate that a user is logged in. Now, there will be a demonstration later on that shows how this interaction can work. This example demonstrates custom attributes on two different slides. The first slide has a couple of definitions, one for a user type's enum, and then a user class, and then a custom security attribute class. Let's take a look at the user type's enum first. Notice here it is a flags enum, so I'm using a predefined attribute. And then we have four values: unknown, guest, power user, and administrator. I just arbitrarily pick these values, and notice since they are flags enums, I can combine them together. Then I have a user class. Notice here in the user class, I have a static user, current user object. This is how I am going to create a singleton user for the entire application. So when you log in, you basically have to provide your user credentials, and then it makes that user, when it authenticates it, the single object available to the entire application. So anytime I want to know what the current user is, I would simply say user.currentUser. Then I have a user types enum value, which indicates the privileges that this particular user has. So for instance, if we want to say that this is a power user, it would be set to power user. Or if it was both power user and guest, it would be power user and then the or guest. Then finally, we have the user's name as a third property. Notice here the constructor is private, and there is no other constructor that's available for the outside world to use. This is done on purpose. That way you cannot just arbitrarily create users through code. You actually have to call some login method, or in fact at the bottom you'll see a load user method, which will create a particular user, and then it takes that user object and sets it to the current user singleton. That way there's only ever one of these user objects in memory during the entire run of the program. The last thing in the user class is this validate user method. Now validate user is going to make use of the attribute defined on the top right hand side of the screen. So let's take a look at that attribute real quick. Notice here it's called custom security attribute, derives from attribute. It has a single property called required user type. Notice that is of type user types. And then this particular attribute can only be applied to methods. You can tell that by looking at the attribute usage attribute that is defined for this particular class. So within the validate user method again, basically we are passing a method info object to this particular method, and we're going to check to see if the method passed in has a custom security attribute applied to it. So the first thing we're going to do is create an array of custom security attributes, and we set it equal to the method info passed in dot get custom attributes type of custom security attribute, and the true basically it signifies whether or not it should look for any derivatives of that type as well. We don't have any, but you can leave it true, so if you ever do derive from custom security attribute, it would find any of the children as well. So that will return a list of all of the, or an array of all of the attributes that match that particular custom attribute name. Now, if the array is either null or zero length, basically it doesn't have that attribute applied. By this usage, since we are checking to see if a user has access to a given method, I'm going to make the assumption that if the attribute was left off of that method, that anybody can use it. So in that case, it is not going to do anything at all. If it does contain an attribute of type custom security, then what it does is checks to see whether or not the current user contains the permissions required by that method. So if you take a look at the required user type of attr index 0, you can say has flag, and you pass the flag of that particular user type. So it's saying, hey, if the method contains the correct attribute and the user has that same attribute, then we're allowed to proceed. However, if it's not found, look at the exclamation mark that says not, then we throw an invalid operation exception indicating that the user does not have permission to execute that method. Now, if we take a look at this slide, we have the process data class, which is just a class that's going to utilize the security attribute. And then we also have the runtime of the code, which is up in the top right, something you might find in the main function of a console application. Let's take a look at the process data class. Notice here it has three methods. We have delete data, load data, save data. For delete data, I have the custom security attribute applied. Notice I left off the word attribute, doesn't need it here. And I say the required user type is equal to usertypes.administrator. So to delete data, you have to be an administrator. And then the first line of that method basically says user.validateUser, and it checks to see whether or not the current method requires that or has permission to be executed by that given user, by the given user. Okay, and notice all three functions start with that very same line of code. Okay, so we are saying we have this attribute applied saying, hey, we require this type of security, and then we check to make sure that the current user has that permission, otherwise it throws the exception. And then the load data method again has a custom security attribute applied to it. This time it has guest, power user, or administrator. So basically any type of user can execute this method. And then finally, save data requires power user and the administrator type. Now, you might ask, well, how is that attribute very useful to us if we don't actually make the call to validate user? And in fact, it's not useful at all. Okay, this is just one of the possible ways you can implement attributes. Remember, it's just a little sticky note that sits on top of a class, method, whatever. So we have this delete data method at the top. Nothing changes inside the code itself if we don't do that validate user call. If we didn't have that, it wouldn't care. Okay? Now this technique is actually commonly used when you have client to server communication, like using WCF for instance, where you have custom security, and then you can funnel all of your server side calls through a given set of static class members that will process your remote calls. So that way you have one point of contact for all of the methods that will be sent across the wire. That allows you to do something like this technique very easily because, again, you have one point of contact. So every time you execute a method remotely, you have to go through a given method of some WCF class, and then it will do this validation check at that time. Again, this is just one example about how attributes can be used. Now, if you want more useful examples, possibly, think of things like serializable and flags. You understand how they work, so that is also another approach you can use with these attributes. Some of the framework class library defined attributes are used very frequently. Adding the information associated with these attributes to the metadata would increase the size of many assemblies. And the CLR gives special treatment to these common attributes. One big one is the serializable attribute. It is actually one of the exceptions where the attribute itself does get applied to the class information or the type that has that particular serializable attribute applied to. So there will be an isSerializable method that is part of the system.type class. So that is one of the few attributes that actually behaves differently than typical attributes. So if you were to try to use getCustomAttributes on the for the serializable attribute, it will not work. Okay, because again, it is handled differently because it is a special type of attribute.